Welcome to the Explainer. Today we're diving straight into a massive, fundamental tension in global trade, the clash between theoretical perfection and, well, physical reality. We're going to explore exactly what happens when we try to perfectly control the inherently uncontrollable global air cargo machine.
Okay, let's dive right into this. I want you to keep one central question in the back of your mind as we go through this explainer. What happens when the world's most optimized network hits an invisible wall? We're going to look at some mind-blowing, cutting-edge research that's trying to perfect logistics, and then we're going to look at a very real, very abrupt event that brought all that theoretical perfection to a grinding halt. Because, let's face it, the stakes between keeping the physical global economy moving and complete utter gridlock are so much higher than most of us realize.
Part 1. The Air Cargo Machine and the Pursuit of Perfection. As Karachi outlined in a 2025 study, the deep nexus between air cargo and international trade pushes this entire industry into a relentless, never-ending pursuit of absolute operational perfection.
And I mean, academics and supply chain pros are literally obsessed with building the perfect logistical machine. It's like a giant puzzle. You've got experts like Zhang in 2025 hyper-focusing on network optimization for intercontinental routes. Then you have teams like Jurgalani Koldava researching the deep digitalization of supply chains, and researchers like Petek focusing entirely on risk management through these massive bibliometric analyses. The ultimate goal across all of these studies, it's simple. Eliminate inefficiency, predict literally every variable, and perfectly control the flow of global trade.
To give you an idea of just how deep this rabbit hole goes, check out this concept, proposed by Malik Dar and Shirazi in 2025. Fuzzy location and allocation hub network design. Now, I know that sounds like a massive mouthful, but the idea is actually brilliant. It's essentially a highly complex mathematical approach used to optimize air cargo transportation networks when you're dealing with an overwhelming amount of complex, constantly shifting variables. Basically, this is how theoretical math tries to tame the massive logistical chaos of the skies. They're using advanced calculus and probability to decide exactly where a hub should be and how cargo should be allocated, all just to save every possible fraction of a cent and second.
And this brilliantly illustrates our absolute reliance on high-tech algorithms to control the supply chain. I mean, think about the tools we're throwing at this problem. Researchers like Rizzo and their team have been building data-driven AI cargo revenue management systems. Philipson's 2024 work literally brings quantum computing into supply chain logistics. We are talking about quantum computing here, the most advanced processing power theoretically possible, just to route boxes more efficiently. Add in hybrid assessment models using fuzzy logic, plus high-stakes time series forecasting from Garg and colleagues, and you've got an industry that honestly believes it can calculate its way out of absolutely any problem.
But this creates a totally fascinating contrast. On one hand, we've got our theoretical optimization, the AI, the quantum computing, the perfect forecasting models we just talked about. This is logistics in a vacuum. But on the other hand, we have the harsh, uncontrollable realities of the physical world. We're talking real-world disruptions, sudden airspace closures, completely grounded fleets, massive system shocks. Because at the end of the day, you can have the absolute most advanced quantum algorithm in the world, but it simply cannot move a plane through closed airspace. No way! Which brings us to the harsh reality check. On March 11, 2026, the industry experienced a massive, real-world plot twist. A sudden system shock that completely disrupted one of the world's major logistics operators. In an instant, all that theoretical math and those gorgeous forecasting models were entirely superseded by a physical, real-world barrier.
On that day, Qatar Airways Cargo, a total leader in global trade, had to issue this official alert: temporary suspension of cargo operations due to airspace closure. Just like that, an external geopolitical reality entirely outside of the airline's control instantly paralyzed a massive segment of a perfectly optimized high-tech network.
This suspension shows us exactly what a severe operational black swan variable actually looks like on the ground. First off, all scheduled flights were temporarily suspended. Everything just stopped. Second, this wasn't something the airline's AI could just brilliantly route around. They were entirely dependent on the Qatar Civil Aviation Authority announcing a safe reopening. Third, it caused an immediate upstream bottleneck. Temporary restrictions were slapped on booking and accepting any new shipments until a new schedule could be figured out. The only tiny sliver of optimization left was that limited freighters not routed through Doha could continue operating.
And man, this creates immediate, intense friction. When the quantum computers hit a physical wall, the fallback is surprisingly manual. Qatar Airways had to immediately activate a customer crisis protocol. Customers were told to manually check their shipment status online, constantly review the website for operational updates, and meticulously monitor their email accounts for rebooking notifications. So the most advanced supply chain in the world suddenly reverts to just refreshing web pages and checking email inboxes when the physical airspace is closed.
So, the crucial point is, how does the industry actually respond to these unavoidable physical shocks? That brings us to part 2, building resilience and managing high-stakes risks. This is where academic research pivots from pure efficiency to, frankly, pure survival. This is exactly where theory and reality meet. Experts are actively studying how to survive these extreme, high-stakes disruptions without losing efficiency across the board. You've got researchers like Sacco and Mishra in 2023 looking at how to optimize the cost of consolidated shipments. Essentially, they're figuring out how to pack things together most efficiently when space suddenly becomes an absolute premium. The TO3 research team in 2025 focused on analyzing past milestones and trends in air cargo to better predict future systemic behaviors. And researchers like Citiati in 2025 are totally dedicated to navigating the specific innovations and challenges in global logistics, fully acknowledging that the real world will always throw unexpected hurdles at our perfect models. They're basically trying to build networks that bend instead of break.
Which leaves us with this final, provocative thought. We are entering an era where AI cargo systems and quantum computing are going to push logistics closer to theoretical perfection than ever before. But as that sudden 2026 airspace closure perfectly demonstrated, a closed sky really doesn't care about your algorithm. So I leave you with this. As technology pushes logistics closer and closer to perfection, can it ever truly outsmart the unpredictable nature of our physical world? Thank you so much for joining me for this explainer. I really hope it gave you a new lens on the invisible machinery operating right above our heads.